Welcome to our module on version control with Git. Today, we'll dive into this essential tool for software development. Git is a powerful distributed version control system designed to revolutionize collaborative development among teams. So, why is Git so important in today's world? Let's explore its critical role in modern software development. Indeed, Git has become absolutely essential for any modern software development workflow and team. First, Git helps you track changes, which is fundamental for any project. It meticulously records every modification made to your codebase, providing a clear and comprehensive history of all work. Next, Git allows teams to collaborate efficiently on their projects. This enables multiple developers to work concurrently on the very same project without conflicts or issues. Furthermore, Git is excellent for effectively managing your entire codebase. It helps you organize and maintain a complete project history, ensuring no work is ever lost or overwritten. Finally, Git plays a crucial role in preventing overwrites, protecting your team's work. You can safely integrate contributions from different team members, ensuring no data loss during merges. Now, let's understand some foundational concepts that make Git so powerful and unique. These foundational concepts are key to mastering version control and leveraging Git effectively. One core concept is Git's distributed nature, which sets it apart from other systems. This means every developer possesses a complete copy of the entire repository and its full history locally. Another important concept is that Git is snapshot-based, not just difference-based. Instead of just saving differences, Git saves snapshots of your project's entire state at each commit. The branching model is also a fundamental and powerful feature in Git. It allows you to work on new features or fixes in isolation, separate from the main codebase. Lastly, Git is highly valued for its integrity and remarkable speed. It's optimized for performance and ensures the reliability and security of your project's valuable data. Let's begin by learning how to initialize a Git repository for your projects. This is the very first step in starting your project with effective version control using Git. To initialize a brand new Git repository in your current directory, you'll use a specific command. You simply type git init in your terminal, and Git sets up the repository for you. Alternatively, you can clone an existing remote repository to your local machine. For this, you use git clone followed by the repository's URL, like the one shown here. Today, we'll dive into how to track and commit changes effectively within your Git repository, which is fundamental for version control. This section focuses on essential Git commands for efficiently managing the ongoing development of your project and its evolution. First, let's learn how to check the current status of your repository, understanding its working directory. The git status command reveals the current state of your working directory and staging area, showing tracked, modified, or ready to commit files. To see this information for yourself, simply type git status into your terminal. Next, we'll cover how to add your modified files to the staging area, preparing them for a commit. The git add command moves changes from your working directory to the staging area. Use git add to stage all modified files. You can add specific files like git add filename, txt, or all modified files with git add. Finally, after staging your changes, you'll commit them to your repository's history with a descriptive message. The git commit m command records these staged changes with a message, creating a permanent snapshot of your work. An example would be git commit m followed by your descriptive message, like added new feature. Now, let's explore the powerful concept of the branching and merging lifecycle in Git, crucial for collaborative development. This cycle is all about isolating different development efforts and then seamlessly integrating them back into the main project. The life cycle begins by creating a new branch, allowing you to work on features independently without affecting the main codebase. Once on your branch, you'll develop your new feature or fix, making all necessary code changes and additions. As you develop, you'll regularly commit your changes to the branch, saving your progress incrementally. After completing your feature, you'll merge your branch's changes back into the main branch, integrating your work. Finally, once your changes are safely merged into the main branch, you can delete the feature branch to keep your repository tidy. Let's now look at the specific Git commands that enable this branching and merging workflow in your projects. These are key commands that facilitate parallel development, allowing multiple team members to work simultaneously. To start, you'll need to create a new branch to encapsulate your independent development efforts. The git branch name command creates a new branch for independent lines of development, but does not switch to it. For instance, you would use git branch feature branch to create a new branch for a specific feature. Once created, you'll need to switch between different branches to work on specific features or fixes. The git checkout branch name or git switch branch name commands let you navigate branches, updating your working directory's state. You can switch with git checkout feature branch or the newer, often preferred, git switch feature branch. After development on a branch is complete, the next crucial step is to merge its changes back into another branch. The git merge branch name command integrates changes from a specified branch into your current active branch, combining their histories. To integrate your feature, simply run git merge feature branch while on your main development branch. Let's explore the feature branch workflow, a common and effective strategy for collaborative development in Git. The workflow begins by ensuring you are on the main branch, which represents the stable version of your project. Next, you create a dedicated feature branch for your specific task, isolating your work from the main codebase. On this feature branch, you will develop your changes and commit them regularly, saving your progress. After making progress, you push your local feature branch to the remote repository, sharing your work with collaborators. Then, you create a pull request, signaling that your feature branch is ready for review by your team members. Finally, after thorough review and approval, your feature branch is merged into the main branch, completing the cycle. Let's now summarize the key concepts we've covered in our session on Git and version control. Our goal has been to understand how mastering Git can significantly contribute to your project's overall success. Remember, Git is a powerful distributed version control system, essential for tracking changes and enabling collaborative development. To begin, you initialize repositories using git init or git clone to start version control for your projects. You use git add to stage changes and git commit to save them into your local repository's history. Branching enables independent development paths, and merging then integrates those completed features back together. Remote commands such as git push and git pull are crucial for synchronizing your local and remote repositories. For effective collaboration, always ensure clear commit messages, frequent synchronization, and proper use of pull requests.